Hello everyone, this is Shweta Patil from Department of E&TC, AISSMS, Institute of Information Technology, Pune. Today we will have a look at the optimal policy page replacement algorithm. The optimal policy page replacement algorithm selects the page for replacement. It selects that page for which the time to the next reference in the future is the longest. This algorithm has the fewest page faults. In practice, this algorithm is impossible to implement. It is not possible to know the future access behavior of the process. Hence, it is impossible to implement. This algorithm, it can be best taken as a standard for judging other replacement algorithms. This algorithm, it can be implemented by maintaining the forward distance, that is the on future uses of each page, and after every page, reference forward distance of the page in the memory is calculated. So working on this optimal algorithm, this algorithm can be more understood by taking one problem. We have a problem here. So a system is using 3 page frames for storing the process page in the main memory. It uses the optimal page replacement policy. So assuming that all the pages frame are initially empty, what is the total number of page faults that has occurred or will occur while processing the page reference string? The string is given below: 47617611272, and we have to calculate the hit ratio also. So we will find the solution to the given problem. Initially we will write all the references in one line, that is 47617611272. Then we have the main memory. This main memory is divided into 3 parts, or we can say 3 frames, and we will draw the 10 slots as we have 10 reference numbers or reference sequences. We are going to solve this problem with the help of optimal page replacement algorithm. Hence, the first sequence which we have is 4. Initially the memory is empty. The 4 will come in the first frame. After that we have the page number 7. So 4 will remain as it is. We will add page number 7. Next is page number 6. 4 remains as it is, 7 remains as it is, and in the remaining frame we put the 6. Now all the 3 frames are filled. Next page is 1. Out of the filled pages, we are going to replace this 1 by the page which is going to be not used in the next future. Here we can see that 7 and 6 are going to be used in the next future. 4 is not going to be used. So 1 will be replaced by 4, 1, 7 and 6. Next reference is 7. 7 is already existing, so we will keep it as it is. After that we have the reference 6. 6 is also existing as it is, so this sequence remains the same, 1, 7, 6. Next sequence is 1. Here we have 1, so 1, 7, 6. This also remains as it is. Next reference is 2. Here now 2 will be replaced by which of this page? As we know that 7 is required in the future, we can replace the 2 with page 1 or 6. Here I will replace it with page number 6. So I will put here 2, here 7 and 1 as it is. Next Sequence is 7. 7 is already existing. So this sequence will continue 172. Again we have 2. 2 also exists. So this sequence also continues to be the same. Now we have to find the number of faults and the number of hits. We will check where we have a hit. So we have a hit here, first hit here. The page numbers are as it is. Here also there is a hit. This also is a hit. You can see from here the page numbers are same. Here it is a change. Here the page number remains same. Here we have a hit. Here also we have a hit. And others are the faults. So this is a fault. This is a fault. Here we also have a fault, and here is also a fault. So to calculate the number of faults, we have just calculate the faults in here. 1, 2, 3, 4, 5. So there are 5 faults, and the number of hits here are, calculate the hits, 1, 2, 3, 4 and 5. So there are 5 hits. In the question they have mentioned to find out the hit ratio. To find out the hit ratio, the formula is given as the total number of page which are hits, here it is 5, divided by the total number of reference, here it is 10. So we have the hit ratio as 0.5, or we can say it as the 50%. So that was about the optimal page replacement policy. Thank you all.